Integration by parts 8. Integral secant cubed x dx. Let's do some review. Derivative of sin x is cos x. Antiderivative of cos x dx is sin x plus c. Derivative of cos x is minus sin x. Antiderivative of sin x dx is minus cos x plus c. Derivative of secant x is sec x tan x. Antiderivative of sec x tan x dx is secant x plus c. Derivative of tangent x is secant squared x. Antiderivative of secant squared x dx is tan x plus c. We also need to know some identities, trig identities. 1 plus tan squared x is secant squared x. Cos squared plus sine squared equals 1. And the half angle formula, sine squared x is 1/2 1 minus cos 2x. Cos squared x is 1/2 1 plus cos 2x. And sine 2x is 2 sine x cos x. Okay, let's start. So we're going to apply integration by parts. Choose u easy to differentiate, choose dv easy to integrate. So let's write this as a product of integral secant x times secant squared x dx. Now you may wonder, how do we come up with this? Why do we write it as a product of secant x times sec squared x dx? It's because we're trying to write it in a form u dv, where we have this is u and this is dv. You see, we can differentiate u, that's just sec x tan x, and we know how to integrate secant squared x dx, that's just tan x. So that's the idea. Okay, so u is equal to secant x, its derivative du is equal to sec x tan x dx. This is dv. dv is equal to secant squared x dx. And to differentiate dv to get v, v is equal to tan x. Now apply the formula. U times v, that's going to be, so let's write it out, u dv is uv minus integral v du. U times v, that's going to be sec x tan x minus integral v, which is tan x, times du, which is sec x tan x dx. And let's call this integral I, because I is equal to integral sec cubed x dx. Okay, we get sec x tan x minus tangent x times tangent x, that's going to give us tan squared x secant x dx. Alright, let's apply a trig identity from before. So we know that 1 plus tan squared x is equal to secant squared x. So we have from the previous page, I is equal to sec x tan x minus integral tan squared x sec x dx. Let's write tan squared x as sec squared x minus 1 times secant x dx. And let's write the other stuff, secant x tan x, I is equal to. So we get I is equal to sec x tan x minus integral secant cubed x multiplying sec squared by sec x minus the multiply 1 by sec x minus secant x dx. Now let's integrate term by term. We get I is equal to sec x tan x minus integral secant cubed x dx. Minus times minus is plus. We get plus integral secant x dx. Now, the problem originally was to find the integral of secant cubed x dx. But notice how the thing we're looking for reappears in the solution. So we're going to bring it to the left-hand side, and we get 2i. 2i is equal to sec x tan x plus, what is antiderivative of secant x? That is antiderivative of secant x, that's going to be ln of sec x plus tan x. I guess I should have added it to our review sheet, so let me do that right here. Integral of secant x dx is equal to ln of sec x plus tan x plus c. All right, let's add constant c. Now divide by 2. Divide all of this by 2. And we get I is equal to sec x tan x divided by 2 plus log of sec x plus tan x divided by 2 plus c over 2. I'm going to call that c1 because it's just an arbitrary constant. All right, that's the solution of integral secant cubed x dx. You may want to try a few other types of question like this. For example, you may want to try e to the x sine x dx. That's the same idea where the solution appears in the question. Or integral cosecant cubed x dx. All right, thanks.